Hello everyone, welcome to Vuzzare Data Science channel. In this video, I will do an analysis on iris dataset, which is a default dataset available in the Seaborn library. So first, I'll solve these questions. First, I've imported the libraries. So the libraries are getting imported. Now I'll load the dataset. So for this, I'll load this into data frame iris, and we will use sns.load dataset, and this will be iris. And for this we will run it like this. So the data set has been loaded. Now we will check the shape of the data. So for this we will use iris.shape and we will run it. So this shows 150 rows are there in the data set and there are 5 columns in our data set. Now we have to print the first 5 rows. So for this we will use iris.head, which shows default 5 uh, rows. If we want to change the value, we can give like 8. It will show the first 8 values. Now we have to check the data types of all the columns. So for this we will use iris dot d types, and this will give us the values like for sepal length, sepal width, petal length, and petal width. A data set is float, and for species we have data type as object or string. Now we have to check for missing values. So for this we will use iris dot is null, and this will show us like values where we have null values, and we have like we want to calculate how many like values are missing. So for this we will use sum. So this shows us that for each of the columns there are no null values in any of the columns. Now we have to see the statistical description of columns. So for this we will use iris.describe, and this will show us the values like count, mean, standard deviation, minimum value 25 percentile, or we can say the first quartile, then 50 percentile, or let's say call it a median, then 75 quartile, and maximum value for each of the parameters like sepal length, sepal width, petal length, and petal width. Now we have to calculate unique values in species column. So for this we will use iris, and we will use this species, and we will use n uniques. We want the count of unique values. So for this we will use n unique. If we want like what are the unique values, then we will use unique. This will give us the values like setosa, versicolor, virginica. Now we want to say, so for this let's say convert it here n unique, so it gives us 3. Now we want the values for each of the species, like the 3 species that we got. So for this we will use iris, and we will pass the column name, which is species, and we will use value counts, and this will give us the values like for setosa there are 50 values, for versicolor there are 50 values, and for virginica there are 50 values. Now we have to sort the data set by sepal length in descending order. So our data set is like this, as you can see. So now we have to sort by sepal length. So for this we will do dot sort values, and we will use by, we have to sort by sepal length, and we have to sort in like descending order. So we will give the value as false. So this will give us like it will, based on sepal length, it has been sorted in negative like descending order. Now filter data where petal length is greater than 1.5. So we will take our data set, and we will have petal length, this should be greater than 1.5, and now we will pass this. So this will generate a boolean indexing for like each of the rows, whether it is greater than 1.5 or not, whether it satisfies the condition or not. And then we will pass this into our data set again, data frame again, and this will like print our, yeah, based on the condition. So we can see that initially we had 150 rows. Now after filtering we have 113 rows. Now we have to check for duplicates. So for this we will do iris dot duplicated. This will like give a true and false value whether it is a duplicate or not. If we will give it like value true and we will pass it into the data set, then we can see whether the rows are duplicate or not. So we can see that row number 142, we can see here that row number 142 is a duplicate. So it has been returned in duplicates. Now we have to find the mean value for different dimensions. So now we have to calculate the mean value for like different dimensions for species. So we will use iris dot group by. So first we'll group by and then using a species, and then we will print the mean. So this will give us the mean values for like different features for different species. Now we have to plot distribution of sepal length. So we can plot distribution using a histogram. So we can write sns dot hist plot, and data will be iris, and on x-axis we will have on y-axis we will have like sepal length. So this will give us a sepal length. So will give us x. So in x we will pass sepal length, and it will print the values like this. We can change like color for this, so we can give different color, like let's say red, print in red color. Now we want to see the variation of sepal length across species using boxplot. So we will use sns.boxplot, and in data we will pass our data frame, which is iris, and we have to see variation of sepal length. So we will pass of sepal length variation of sepal length. So see, it has given like us overall value, like overall distribution of sepal length, but we have to um, find it using for different species. So for this we have used a axis level diagram, a figure, but now we will use a figure level plot, which is sns dot which is a distribution plot. So we will use this plot, and data will be iris, and in x-axis we will have our sepal length, and we will differentiate using a column parameter. So in column we will pass species, so it will give us like three different subplots like this. See, so like this it will give us like three different plots, each for like one for each. Now we have to see variation of KD plot, variation of sepal width across species using KD plot. So we will do the same SNS dot uh, this plot. This is a type of like figure level parameter. So this is like used better for overall analysis, overall visualization, because we can like give separate, we can generate subplots using column or row parameters, or based on hue it will give like multiple subplots. We will not have to create subplots on our own. So again we'll give the data as iris, and we will like give our x-axis as sepal width, and kind we have to give what kind of plot we have to do, and we will give it as KDE. And in column we can give species, and also we can use plt.show, so it will show the chart like this. See, it has given like three charts. If I can give like figure size is small, plt.figure fig size is equal to, we'll pass a tuple here. Let's say it is 6 comma 4, so it will generate like in a shorter axis. So again, it has like differentiated based on like different species. It has created three different KD plots. Now we have to see pair plot for all numerical columns colored by species. So we'll have sns.pairplot, and we will give data as iris, and for all numerical columns, so like it will by general creates for all numerical columns only. And in hue we will give species. So hue basically differentiates based on uh, color. So it will generate a pair plot which will help us analyze what kind of relationship is there between these uh, columns. So as you can see, I've got a 4 into 4 kind of plot. So I have the legend here, like blue is for Setosa, orange is for Versicle, and green is for Virginica. So in the like it plots based on like simple like two parameters on the y-axis and the value on the x-axis. So for others it has given us scatter plot, but like where it is comparing it with itself, like sepal length with sepal length. So this cannot be generated as a point. So this will give us a KDE plot. So if the overlapping in KDE plot is less, as you can see here, the overlapping is very high. But let's say if the plotting here is less, overlapping here is less, so it shows that like, this parameter can be used for independent analysis. Let's say petal length, it can be used for differentiation between these. Also petal width, also if the line is like a 45-degree, as you can see here, it shows that it has a good relationship. Like petal length and petal width are kind of related, at least for these two values, like green and orange color values. Now I have to do box plot analysis for petal length for different species. So I'll do sns.boxplot, and in data I will pass the iris data set, and I will have like for petal length, so I will give x value as petal length, and for different species. So also like instead of, so I will have to separate, so instead of box plot I can use a figure level diagram here, which is this plot. No, box plot is in cat plot, and here I can give like what kind of plot I want. So I can give kind is equal to box, and in this I can pass like column is equal to species, so it will differentiate based on the species. So see, has like given us three columns. So first is for petal length, second is for first is for setosa, second is for versicolor, and third is for virginica. So like this we can create a facet grid, but this is like figure level, and we can already like create subplots based on this column parameter. Now I have to show correlation for different columns. So I can use a correlation like iris dot correlation, and in this I'll use numeric only and pass it as true. So if I see my matrix will be like this. So here it will have numbers. So for this we'll have heat map. So heat map will be created like this. So we will like format the heat map. So for annotation it will be true. So it will show the values now. And format of the data will be like 0.2f. So it will show like 2 points after decimal. And we can give the color as CMap is equal to cool warm. So it will show values like this, but you can see the minimum value here is 0.4 because in our data set it represents up to there only, like 0.43 is like minimum. So we can give like minimum and max values also. So we can give v minimum is equal to -1 and v max is already 1, but let's say give it as 1. So now it gives -1. So here it was like appearing much blue. So it was like it showed a strong negative correlation, but now it shows that it's a moderate negative correlation. So based on like our minimum scale came to -1. Now I have to identify relationship between petal length and petal width. So for this we will use scatter plot because using a scatter plot we can identify the relationship. So in x-axis we can give like petal length, and in y-axis we can give like petal width, and I can create the scatter plot. So it shows the scatter plot like this. If you want like for different species, then you can give a hue. It will create different color for different species, but like overall we wanted to identify the relationship, so it shows that it has a good relationship like for these two. And also you can verify using correlation matrix, petal length and petal width. So we have petal length here and we have petal width, so it is like 0.96. So it shows very good relationship. So this is what is being shown, because if the line slope of the line points are like 45 degree, then it shows positive relationship. Plot mean sepal length with error bar for each species. So we will use SNS dot bar. Data will be like iris, and on x-axis we will have sepal length. No, on y-axis we will have sepal length, and on x-axis we will have species. So it has given us like box bar plot like this, and these are the like median values, mean values, sorry. Now I have to identify features with highest and lowest variance. So for this we will use iris dot var. So for variance we will pass the parameter numeric only, and this will be true. So we will have like variance for all the features, sepal length, sepal width, and rest too. So it shows how much variance is there, and we can store it in a variable. And we can also identify features with largest variance. So for this we will use variance like print largest variance, and we can give value here variance dot index max. So this will give us the largest variance. Petal length has the largest variance, and similarly if let's say we want for minimum, so we can give print and smallest variance and this will be like variance dot index min, and this will give us like which has like sepal width as the smallest variance. Now I have to create a violin plot for each feature grouped by species. So we'll use SNS dot violin plot, and data we will pass as our data frame iris, and for each feature. So for X we will give the features like species, and in Y we will give all the features. But our features are like in different columns only, so we cannot give it like this. We'll create like iris dot columns, will give us all the column names, and we will create like numeric columns, numeric columns, and we will pass these values into it, and we will have like for feature in numeric columns SNS dot, so we'll have create a figure, then plt dot figure, and we'll have fig size, it says 4,2, and then we'll create SNS dot violin plot, in data we will give our data set which is iris, and in x-axis we will give species, in y-axis I'll give feature, and I'll use plt.show. So this will give us like a violin plot for different features. So first param feature is like say sepal length, so it has given like violin plot for all of these separately. Now for sepal width, similarly for petal length, and similarly for petal width, it has given like violin plot. Now I have to see count plot, and also add data labels on the bars. So for this I can give like SNS dot count plot, and I'll pass data as iris, and in x-axis I'll pass the species. So it will just give us a count plot like this. But I have also give the data labels here, so I will store it in a value axis, and then I'll give like for container in axis dot containers, and I will use axis dot bar label, and in this I'll pass the value as container. So this will give us the values here, 50, 50, and 50 for each of the values. Now I have to find top 5 samples with largest sepal length. So for this I will use iris dot n largest function, and I will pass the value 5, and I have to find based on sepal length. So I will pass the column name sepal length here, and I'll get like based on sepal length top 5 values. These are the rows like 131, 117. In these rows we'll get those values. I have to plot the KDE plot for petal width by species. Petal width by species. So we'll use SNS.displot, and I'll pass the data set as data or iris data set, and then I'll use petal width for species. So in X, no, for X we'll give, let's say, petal width, and in column we will differentiate, like it will create 3 different subplots based on species. I can create it like this. So it has created three different subplots like this. Let's say minimize the screen, so it will show like this. Now I have to mask values in correlation heat map. So as you can see in heat map, we can have it gives a matrix like this, but the diagonal values are always like 1 because its correlation with itself will be 1. And on like the mirror images, these are like mirror images, sepal width, and there also sepal width on y-axis. So like upper diagonal and lower diagonal are similar. So if we want to mask it, so we can create a mask value for this. So what we will first do is we'll create a correlation heat map like iris dot correlation, and we will have numeric only. This will be true, and we will create a heat map in this, and we let's say we give the color map is equal to cool warm, and annotation is equal to let's say true. So this has created a heat map for us. What we can do is we can create a mask and we will pass it as a parameter. So we can create a mask like this and p dot. So for this we'll have to like import our numpy library also. So we'll use import numpy as np, and then we'll use np dot zeros, np dot ones. So we will create, let's say we have 4 into 4 matrix, so we'll create np dot ones, and we'll create it like 4 comma 4, and we'll give the data type as int. So if you see, if I print the mask, you can see it like this. It has a matrix 1 comma 1 like this, but we have to like give the lower triangle as 0, and the one upper triangle will be 1, so that will be considered true and that will be marked. Or let's say we give the data type as bool, but it is like true for 1 everything. Now let's say give it as int only. So now what we'll do is for I in range, and we have like mask, this is like this only, and we have for j in range I, will give mask I comma j equal to 0. So these will become 0. Oh, so we have to give length here. This will be length, and now we'll print. So we'll have let's say data is 0 0 0. So these will be only printed and the rest above will be ignored. So now we'll pass into our data mask is equal to mask, and the heat map presented now will be like this. So we'll remove this line and we'll print like this only now. So it is showing us like this now. Now I have to show the distribution of points using swarm plot for petal width. So I'll do sns dot swarm plot, and data will be iris, and in x-axis I'll give the species, and in y I'll give for petal width. So petal width will be there, and it will create a swarm plot for me like this. Like it shows a original distribution of like points where they are. So the mostly for Setusa you can see points are like this in the range of 0 to like 0.67 up to like that only. For versicolor, you can see like it's above 1 and it's like around 2, and how many points are in which range you can see from here. You can see that for Virginica, like most of the higher side, most are on the higher side, and less are on the, let's say, 1 point less than 1.8. Now I have to identify outliers in petal length for Setosa species. So first I'll identify Setosa. So I'll create a Setosa data frame, and this will be like iris. And in iris I'll filter using like petal length, use species equal to Setosa. So let's print this data and see what we get. There's not printing, so let's see here. Iris dot species dot unique. So it has to be small. So now we are getting the data. So this will be like for, let's check the shape also. Is it like 50 or not? So again, you can see the size is 50. So this is only for Setosa dataset. And now I have to find outliers in petal length using IQR method. So we will find the Q1, Q2, and Q3 first. So Q1 will be like Setosa, and I'll have to find petal length dot quartile 0.25. So let's print out this. This will be quantile. So it is 1.4. Now I'll find the Q2, which is median. So we'll do the same thing. And I'll pass the value as median here. And I'll print Q2 also. So it is 1.5. Now I have to identify Q3. So Q3 will be just 0.75, which is 75th percentile. So this will be like this. And if you print Q3, it will be like this, 1.57 for Setosa species. Now I have to find the IQR. So interquartile range will be Q3 minus Q1. So if I print IQR, it will be 0.175. Now let's say if I want to find a range outside the whiskers area, so it will be range will be first will be Q1 minus IQR. Q1 minus 1.5 into IQR, and the other one will be Q3 plus 1.5 into IQR. So this will be our range. So let's say print our range will give us a value like 1.375, 1.37 and 1.83. This is our, yeah, like outliers. If the value is after this, then we have outliers. So we'll create one outliers list, and we'll pass the points. So far, let's say for X in Setosa, and we have petal length, and I can check if X is less than range, and we'll pass the first parameter of range, and x is greater than range, pass the second value of range. Then it will be added to the outliers data list. So we'll add this, and now we'll print our outliers. We can remove these lines now. Sorry. This will be removed. This will be removed. Let's run this. So for here, we cannot pass bitwise. We have to pass like this. So we do not have any outliers in the data set. Now I have to show the difference in min and max values for different features. So I can use like describe iris.describe. This will show min and max values. I can use store in like this description variable, and I will use like lock here, and I'll see what values I need. So I need min and max values. So I'll pass both of them as list here, min and max. So print it, so it will give us value. So here we have used iris. I'll use description.lock. So this will give us like this. Now I have to transpose this data. Use description.transpose, and I'll print it again. So this will give us like transposed matrix. So I'll have min and max values here. Now what I have to do is I have to create min max difference. So I'll use min, I'll create a new column, min max difference, and it will be like description, and the value is max minus description min. And if we print our data set, it will be like this now. So it has values min max difference for each of the features. So that is all in this video, guys. Thank you for watching it. Do subscribe for more videos on Python. Thank you.